So in the first part of chapter 14, part 2 I guess we called it, so we'll call it 2A now. Basically what we are looking at is how to actually go through and compute confidence intervals. So now what we're going to do is just a couple of different types of examples. So I showed you how to use or calculate confidence intervals, but we can also find different things such as sample size for these. So we'll look at those calculations in this example, and then more of a reasoning type question for the last example in this part of the notes. Okay, so looking at this, example 3 says, a recent general social survey asked respondents, on the average day, how many hours do you personally watch television? So same as what we were doing before. Assume that the number of hours of television watched by U.S. residents is normally distributed with a standard deviation of 2.5. Okay, so we still know that we have U.S. residents that's normally distributed, aka we can use a bell curve, with a standard deviation of 2.5. I know that means sigma equals 2.5, again because it says U.S. residents. Okay, so that's population in general. Okay, at a 95% confidence level, how many people would you have to interview in order to bring the margin of error down to 0.075? Okay, so notice we're asking how many people. This means that we're going to have to want to find n. Okay, how are we going to do this? We're going to use the margin of error formula because it says to bring the margin of error down to 0.085. Okay, so we need to use the margin of error formula to do this. Since given info about the margin of error. Okay, so what I'm going to do is start with my margin of error formula. Margin of error, I know that's equal to z times sigma over root n. Okay, now I know that I want my margin of error to equal to 0.0785. So I know I want this to be 0.0785. Okay, here I'm doing this at a 95% confidence level. So again, I already know what this value is, but if I wanted to, I could look this up. 95% confidence, go down to my z-score, and it's 1.96. Okay, so I know I have 1.96. That's because this is 95% confidence z-score. Okay, technically that's from table C. Okay, and then I know that my sigma was given as 2.5. Okay, I don't know my root n, so I'm just rewriting that there. Right, so at this point, basically what we're going to do is something similar to what we've done before, except for our formula is a little bit more complex, and that's just solve for root n using some algebra. Okay, so first, I'm just going to multiply my 1.96 and 2.5 together, so I only have to work with one term there. So this is the same as 0.0785 equals 4.9 over root n. Okay, I'm going to multiply root n over to the other side, so I get 0.0785 times root n equals 4.9. Okay, now I'm going to divide 4.9 by 0.0785 to get root n equals 62.42. Okay, squaring both sides, we would get n equals approximately 3,896 people. Okay, so basically to recap that a little bit, we started with a population standard deviation. That was 2.5. We knew that because it was just talking about U.S. residents in general. Okay, we wanted to figure out what n was, so we know we're going to have to do some algebra when we see that running in there. And then since we're given what we want the margin of error to be, that's why we use the margin of error formula to do this. Okay, from filling in the values in the formula, we just had to go through algebra to solve for n. Okay, so final question in terms of these notes we're going to have to look at. We're going to have to look at more later in terms of chapter 14 and 15, but final example for these section of notes is more of a reasoning question. Okay, so what we're going to do is explain the meaning of the following report. So this says, about 6 months after the highly contested presidential election in Kenya, a majority of Kenyans, 70% of them, told Gallup that they thought the election was dishonest. For results based on the total sample of national adults in 2008, one can say with 95% confidence that the maximum margin of sample error is plus or minus 3 percentage points. Okay, so what this means is 75% of the Kenyans told the Gallup that they thought this was dishonest. Okay, if we're looking at this with a 95% confidence interval, plus or minus 3 percentage point, we're basically just moving 3 to the left of 70 and 3% to the right of 70. I'll write out what this would mean in terms of an explanation. Okay, so what this means is, say this means that we would estimate, the population mean, okay, for people who thought the election was dishonest, to be between 67%, so that's where the minus 3 percentage points comes, and let's see, 73%. And that's with 95% confidence. Okay, and technically what we're given right here is really, it says population mean, but we're looking at the population mean in terms of the proportion. So since we had that 70%, we're really looking at a proportion of that Kenyan population for that. Okay, so this will wrap up the chapter 14 part 2 notes. When we get into chapter 14 part 3, I think it is, we're going to get a little bit more vocab and reasoning in there, and then we're going to kind of combine computations from chapter 14 and 15 to finish up a pretty big chunk of notes in terms to that. So those videos will be to come, but for now, I'll post next ones.